So, on page 335, it says that during intermission of sporting events, it's become common for them to launch t-shirts. So, the mascot is out in the field, and he launches a t-shirt into the stands. So the t-shirt gets launched up, and it says after peaking, it comes back down, and a fan catches it who is 70 feet off the ground. Good so far? Isn't that how Ned Flanders' wife died?
Yeah.
Yep.
Alright, so, what was her name? Maud Flanders is up here catching this t-shirt, not very skillfully. Falling off like Chris off the back. Alright, so t-shirt gets launched. This person catches it who's 70 feet up in the stands. Good so far? Alright, so it says that the height in feet after t seconds is given by this function. Negative 15t squared plus 75t plus 10. Alright, I just said it out loud, but see if you remember what I said. Let's do the function nag. Input is standing for what? Not height. Time? Measured in seconds. Yes, the height is given by this function after t seconds. So therefore, what's the output? Height, and it's measured in feet. So if I input 5, what does that mean? 5 seconds, and I'd run through the math, and it would tell me how high the t-shirt was after 5 seconds. If I output 5, what does that mean? 5 feet, so that would mean the t-shirt's 5 feet off the ground. We all right with that? Okay. We can't really function nag the rest of it because this isn't slope, so there's no slope to really mean anything about a rate of change, and there's no... Well, there is a y-intercept, but it's not anything you know about. Just in case you're ever going to take a physics class, this piece is talking about acceleration due to gravity. It's negative because gravity is pulling it back towards the Earth. This piece is about the velocity, and this piece is about the initial height. So I actually this problem's not very realistic because it's the mascot that's shooting this is 10 feet off the ground, or 10 feet tall maybe, I don't know. So whatever, that's what those pieces mean, but we're not going to function nag the rest of it. Input and output. Time in seconds, output feet. We're good? Alright, so the question says, how much time has elapsed when the person catches the t-shirt? So the person catches the t-shirt at 70 feet off the ground, right? Is 70 an input or an output? It's an output. So don't plug it in, set it equal to. So this is saying, if this function tells you how high the t-shirt is, and we know that it's 70 feet high, we can now solve it and figure out what t is, and that will be how long the t-shirt was flying. Does that make sense? So they gave us an output, we can find what input gives us that output. Good? Alright, so let's just solve this using methods we learned last time. What should we do first? Do what? Oh, let's get this 70 because we should get them set equal to 0 first. Alright. Negative 15t squared plus 75t minus 60 equals 0. Now what?
See what the greatest common factor is?
Which happens to be... Who bigger than 5? 15?
Oh.
Should we take out negative 15? Alright, so if we take out negative 15...
I have a question about that.
Yeah.
75 isn't negative, so why would you be taking out?
I want to take out the negative so that if I leave the negative in, I'll have negative t squared, and therefore it won't be shortcut eligible because there's a negative 1 in front of it. I want to make it shortcut eligible, so take the negative. Which, you're right, 75 is not negative. What's it going to do to that part?
Make it negative.
Make it negative. So if I factor out a negative 15, I'm left with positive t squared. This is going to be negative now. Negative 5t. And what's going to happen to the negative 60? Positive 4 equals 0. If I had just taken out a positive 15, we'd have negative t squared plus 5t and negative 4, which is factorable. It just is not shortcut eligible, and it would be really nice to just use the shortcut on this. So the cool thing about this equals 0 business is we can divide by negative 15 on both sides, and it just goes away, because 0 divided by negative 15 stays 0. So we're working with t squared minus 5t plus 4 equals 0. We need factors of what that add up to what?
4 that add up to -5.
Good. Factors of 4 that add up to -5. -4, -1. -4 times -1 is positive 4. -4 plus -1 is -5. And we purposely made this one shortcut eligible, so we don't have to do any of that grouping stuff. We can just go straight to t minus 1 equals 0. So set each chunk equal to 0. T equals 4, t equals 1. Alright, we just got two answers. They both are going to work if we plug it in and check. Look back at that picture. Doesn't it hit 70 feet twice? I know this is really unrealistic. This is like the world's longest hang time t-shirt. It's made out of helium or something and just floats. But it shoots up and hits 70 feet and then keeps going and hits 70 feet again. So at what time does it hit 70 feet the first time? At 1 second. What time does it hit it the second time? And the instructions in this problem did say that the fan catches it after it peaks. So which one's the answer to this problem?
4 seconds.
Alright, so the answer is they catch it after 4 seconds. That's just a little bit ridiculous. Isn't like hang time for a football kickoff only like 3 point something seconds? Alright, so this 10-foot tall mascot is really far away and this t-shirt is really light. Okay, but and it killed the person that caught it because they fell off. Alright. Any questions about this setup though? Alright. Yeah.
Will most problems be set up like that, or will they be different?
The story problems, like in general, there's 3 different kinds of story problems that you're going to see in here. This one is called projectile motion, which actually pretty much everything that you can shoot follows a projectile path, like cannonballs fly like that. Bullets actually fly like that too. They're just so small you can't see it. Bullets taper off like that, which is, if this is the gun, you can't see it do that because it's not that dramatic, but it does follow the bottom half of a parabola. Anything that you shoot follows that because gravity's pulling it down. The other kind of problems we're going to do, one of them is like a construed problem where nobody would do this in real life, but it mathematically makes sense. We'll do this patio one next. And the last one is also a geometry. The last 2 are both geometry problems. So this is, I like these story problems better, but no, they're not all going to be like that. Simple answer, no, they won't all be like that. Any other questions? All right, but are they all going to be solving like this? Yes, they're all going to be quadratic problems that have a squared and not squared in a constant term, and we're going to factor it and get 2 answers. That part, yes, will always be in all of these story problems. All right, so next story problem says that Lucinda and Felipe want to build a patio on the back of their house, and instead of building a nice normal rectangle patio, you're going to build a triangle patio. And not only that, but Lucinda remembers from a geometry course that she took some weird math relation that she wants to embed in her patio. So it says that they plant a stake out here, and they want it to hit the house at a perfect 90 degrees, and they want it to be a triangular shaped patio. And not just any triangular shaped patio, but she remembers from her geometry course that there are 3 consecutive integers that make right triangles. Remember, right triangles have to follow what rule? What's that Pythagorean theorem rule?
A squared plus b squared equals c squared.
A squared plus b squared equals c squared. And on a right triangle, which one has to be c? This one, the hypotenuse, the longest side, and it's always the one that doesn't touch the right angle. And then A and B don't matter as much. They've just got to be the ones that make the legs or the ones that form the right angle. So that's the rules that work for right triangles. And she says she remembers 3 consecutive integers that work for this. What does consecutive integers mean?
It means that it's like 1, 2, 3.
1, 2, 3. So they're integers, they're whole numbers, they're not fractions, and consecutive means they come one right after the other. So 1, 2, 3 is a perfect example of consecutive integers. They happen to not be the answer to this problem, unfortunately. So since we don't know what the consecutive integers are, in math, what do we call stuff if we don't know what it is? So if the first one is x, what's the next one? X plus 1 would keep less variables. What would be the next one?
X plus 2.
X plus 2? Only because they're consecutive, right? What if it said something like consecutive even integers? Then it'd be like x plus 2, and x plus 4? Okay. So, but anyway, these are not consecutive even ones, they're consecutive regular ones. Which one of those 3 numbers is the biggest?
X plus 2.
X plus 2. Therefore, on Lucinda's patio, x plus 2 has to be the c side. And the way I've drawn this triangle, which is not necessarily the way they're going to build their patio, which one? B we'll call x plus 1. That one looks longer than the a side. So a is the x one. Any questions so far? Okay. Erase that. We've decided that x plus 2 is the longest side, and x plus 1 are the legs. All we need to do is plug that into the Pythagorean theorem now. We know that a squared plus b squared equals c squared. Therefore, x squared plus x plus 1 squared has to equal x plus 2 squared. You agree with that? Alright, so all we need to do is solve this equation and figure out what x is, and then we'll be able to figure out all the numbers. Make sure that you have not forgotten from when you first learned foiling that this does not mean x squared plus 1 squared. This means x plus 1 times x plus 1, and you have to FOIL it. It's a common thing to forget. People would get mixed up between like x times 5 and x plus 5 squared. Huge difference here. In this one, it is perfectly acceptable to just square both of those and be done with it. It is not perfectly acceptable to just square both of these and be done with it. You've got to FOIL. If you do this, this is F and this is L, but you've totally neglected O and I. So don't forget that. So let's write this and go through the foiling. X plus 1 squared means x plus 1 times x plus 1. And x plus 2 squared means x plus 2 times x plus 2. Alright, so on the left side, what do we got? We got x squared first. First is x squared. Outside? There's the plus x. Inside? Plus x. Last? Plus 1. On the right side, first, x squared plus 2x plus another 2x plus 4. Good? Alright, before we start trying to combine like terms, should we just subtract an x squared off both sides and be done with that? What else could we just get rid of off both sides and be done with? So those 2 x's and one of those 2 x's? Alright, so looks like we've got x squared plus 1 equals 2x plus 4. Let's make this look like a quadratic like we did in the last problem. What's that going to look like?
X squared minus 2 plus
X squared minus 2x minus 3 equals 0. So essentially, what did we do? We subtracted 2x off both sides and subtracted 4 off both sides and ended up with that. X squared minus 2x minus 3 equals 0. Any questions up to this point? We're good? Alright, let's solve this now. What are we looking for?
Factors of -3 that equal -2.
Alright, which are going to be what?
-3,
-3, positive 1. So x plus 1 times x minus 3 equals 0. Now we just set those two chunks equal to 0. We get x plus 1 equals 0 and x minus 3 equals 0. What's the two answers?
-1 and 3.
Which one of these answers does not make sense in this problem? -1. It does not make any sense to have a triangle whose length is -1. That would be like an inside-out interdimensional triangle. So this is called an extraneous solution. It's not that it's incorrect. If you plugged it back in, it would work. It just doesn't make sense in terms of a real triangle. This would be like an inside-out triangle that's inside the house in another time continuum or something. It doesn't make sense. So 3 is one side of our triangle. And the way we've drawn it, it's the short side. So what's this side? What's this side? You ever heard of a 3, 4, 5 triangle? Anyone who does much carpentry would know about a 3, 4, 5 triangle. It's a really easy way for carpentry to check to make sure they've got right angles. Like lots of carpenter squares are actually built with 3 inches by 4 inches and 5 inches, just to make sure that you're square when you're building sheds and stuff. All right.
Just exclude the -1.
Yeah. It actually works mathematically. So if -1 was x, what would be the next consecutive integer?
I just.
And the next one would be 1?
Wrong if I went that far, you know.
Oh, no, in these kind of story problems, there's very often an answer that doesn't make sense visually, but mathematically it does.
Okay.
I think you're actually going to do a problem a lot like this in 1050, and you're finding possible areas of a triangle, and it follows this pattern, but you're only interested in stuff in this quadrant, because if it's in this quadrant, you've got negative side lengths of stuff, and it doesn't make sense to have a negative side length. I mean, mathematically it works out just fine, but it doesn't work visually to build a patio like that. Okay, any other questions? So this would work if we put this in the Pythagorean theorem. -1 squared plus 0 squared does indeed equal 1 squared. Kind of weird, but don't try to build your patio like that. Probably don't try to build your patio like that either. You're gonna put like a little chair right here on the end. You'll fall off. You trip over that in the snow. Don't do that. All right, last story problem. This problem is about a valuable sports card that somebody wants to encase in lucite, whatever that is, some sort of plastic stuff, to keep it safe. So here's our valuable sports card. And when they put it in the plastic, the lucite, they want it to look nice. So they want it perfectly centered inside the plastic. Pretend that's perfectly centered. That's really not very good. All right, pretend that's perfectly centered. We good so far? Sports card in the plastic. The only thing we know about this is the sports card. It says the dimensions of the sports card are 4 centimeters by 5 centimeters. The other thing we know is it says the area of the lucite, the area of the plastic, is 5.5 times the area of the card. what are the dimensions of this lucite? Meaning, how wide is it, how tall is it? So let's start with what we know. The area, what's the area of the card? 20 square centimeters. 4 centimeters by 5 centimeters makes 20 centimeters squared. So if that's the area of the card, and we know the area of plastic has to be 5.5 times that, don't we just go 5.5 times 20? So what's the area of the plastic? 110? 5.5 times 20 is 110?
Whoa, how did you, I lost you there in a second.
It says that
Plastic.
right in the story problem, it says the area of the lucite is 5.5 times
Oh, okay, I see that wrong.
the area of the card. So I just times the area of the card by 5.5. Alright? That doesn't tell us the dimensions though. There's infinitely many things we could times together to get 110. It could be 1 centimeter wide and 110 centimeters tall. That's probably not what this is like. But there's lots of things that this could be. So we gotta figure out the dimensions. Here's how we're gonna do this. Imagine that I scoot this card down. Straight down. How wide is this piece? This piece, we don't know how wide it is. What do we call stuff we don't know in math? Right? And it says it's perfectly centered, right? It's a uniform border. So how wide is that part? It's also x, right? Does that make sense? So therefore, how wide is this whole card? Or the whole plastic? Can I put the x first? 2x plus 4? Does that make sense? Alright. Similar thought process for this. Scoot the card over in your mind all the way to the edge. How wide is that piece? 5. How wide is this piece? Still x because it's a uniform border. We want it to be perfectly centered. So how wide is this, or how tall is this going to be then? 2x plus 5? Any questions about getting that 2x plus 5 and 2x plus 4? Alright, so now we can make an expression for this. If area is length times width equals the area, right? We can just put this in. 2x plus 4 times 2x plus 5 equals what? 110? So we just need to solve this equation just like we did in the last 2 story problems, figure out what x is, and then x isn't the answer to the problem because it wants to know the dimensions of this, so we'll just have to plug x in and figure it out the rest of the way. But let's figure out what x is. What should we do? FOIL first? 4x squared outside plus 10x inside plus 8x last plus 20 equals 110. So 4x squared plus 18x plus subtract 110 off. What do we get? Minus 90 equals 0. Anything factor out? 2. Really too bad a 4 doesn't. But 2 is going to come out. That'll make our life a little bit easier. So if we take out this 2, what are we left with? 2x squared plus 9x minus 45 equals 0. Get rid of this 2. Alright, so the problem we're going to need to solve is 2x squared plus 9x minus 45 equals 0. Unfortunately, we can't get rid of that 2, which means we are forced into doing 2 times negative 45 and actually doing all of the grouping stuff. No shortcuts on this one. What is 2 times negative 45? Negative 90. So we need factors of negative 90 that add up to 9. I'd probably have to get out my calculator for this, and it's just not going to be 1 and 90, it's not going to be 2 and 45, not gonna be 3 and 30. Doesn't divide by 4. 6 and 15. So 6 times 15 is 90. We need one of them to be negative. Which one? So negative 6 times 15 is negative 90, and negative 6 plus 15 is 9. We alright with that? Okay. So 2x squared minus 6x plus 15x minus 45 equals 0. What comes out of the first group? 2x. Leaves us with x minus 3. What comes out of the second group? 15. Leaves us with x minus 3. Good. So undistributed the x minus 3s, we're going to have x minus 3 times